Hi friends, so today we will start a new series in the channel baseyourbtech, that is from linear algebra. Linear algebra has a topic coming under as matrices, and what actually is a matrix is an array of numbers arranged in rows and columns. See, a basic equation, I mean a linear equation, that is, for example, 2x plus 3y is equal to 6. This is a perfect equation, and we can see that two unknowns x and y has got its power raised to 1, isn't it? X has the power 1 and y is also having the power 1, which is why it is termed as a linear equation. Linear means it will have the power raised to 1. Okay, the unknown variables will be raised to its power 1. So this is a linear equation, and let's take another linear equation, that is 3x minus 4y is equal to 7. So we have two linear equations, and we can solve these two equations and get the values of x and y, isn't it? And there are many methods to get the values for x and y, and matrices render as a different method to find out the values for x and y. Okay, so matrix has its own method of solving these two linear equations. So actually the purpose of matrix is to solve linear equations, and actually these two equations can be solved in many easy methods. But what about what if we have more than 10 number of equations, like 3x equal to 7 and 4x minus 3 by 2 y is equal to 10, and many more equations, even 20 equations, 30 equations. So then it will be very tedious to find the unknown variables x and y, isn't it? So at that point of time and all, we can very much make use of this topic, matrices. Okay, so let's see how this matrix is drawn. As I said, matrix is an array of numbers arranged in rows and columns. For example, 2, 3, 4, 3, 7, 8. Here are the numbers arranged in rows and columns, and we will accommodate all these numbers in two square brackets. This is how a matrix is represented, and let us name this as matrix A. Okay, so matrix will have a square brackets inside which we will have an array of numbers arranged in rows and columns. These are rows. The horizontal lines are rows, and these are columns. Okay, so here I have two number of rows, isn't it? This is row 1 and this is row 2, and this is column 1, here comes column 2, and lastly column 3, isn't it? And we will have another term which is called order of a matrix A. Okay, we will have order of a matrix, and it is actually row by column. That is, for this particular matrix, number of rows is 2. So it is 2 by number of columns is 3. So this is a matrix A which has its order 2 by 3. Okay, and even we can address each of these numbers, like, see, the matrix is termed as capital A, isn't it? So small letter A, 1, 1 indicates the number written in the first row, first column for the matrix capital A. Okay, so here A11 is equal to 2. Got it? And next, what about A12? So this is the number written in the first row and second column. Okay, the first number indicates the row number and second number is for column. Okay, so first row, second column contains the number 3, and there goes 1, 3, A13 is 4, and randomly let us take A 2, 3. What is that? second row and third column. Second row and third column contains the number 8. So A23 is 8. Okay. So generally we write it as AMN, where M is the symbol for row and N is the symbol for column. Okay. So that's it, and the order we write generally it as M by N. Okay. So that is the order. So this is a basic structure of matrix, and as I said, matrix is basically used to solve n number of linear equations, specifically linear equations. Okay, and that's it. So how do we operate such matrices? Let me take that too for this video. That is, I am going to have one more matrix and let's name it as B. Okay. I will have 3, -1, 0, 3 by 2, which means a matrix can even have negative numbers, a 0, a fraction, anything. Okay. And what about the order of this matrix B? It is 2 rows and 2 columns. So it is 2 by 2. We usually write the order in the bottom right of each matrix. Okay. And here it is 2 by 3. Okay. And this matrix B is having the number of rows and columns equal. So we name such matrix as square matrix. This is just a terminology, a type of matrix. Okay, this is a general matrix which is having different number of rows and columns, but here we call it as square matrix because just as in a square we have same edges, right? Here also we are having same number of rows and columns. Fine, and I'll take another matrix C, which is having also C is a square matrix. Okay, 3, 0, 0, 0, 5, 0, 0, 0, -1. See, this again is a square matrix of order 3, isn't it? If the number of rows and columns are equal, we can call or we can write the order of the matrix as 3 itself. Order of the matrix is 3. Order of this square matrix is 3. That's all. Because since it is a square matrix, it is understood that it is having both its rows and columns equal to 3. This is also a square matrix of order 2. We just need to say order 2 because it's a square matrix. So it will have number of rows and columns equal to 2. Okay, that is just a point. And so here comes the matrix C, and you can see that here only the diagonal of the matrix is having non-zero values. The other values is equal to 0. So here the diagonal elements are only the non-zero values. So we call such matrix as diagonal matrix. Okay. So when I talk about the diagonal of a matrix, it should be the principal diagonal being taken. Okay. This is the principal diagonal. So when we speak about the diagonal of a matrix, it is understood that that should be the principal diagonal, the main diagonal or principal diagonal. Okay. We know that there are 2 diagonals for a square, but when we talk about the diagonal of a matrix, it is understood, it should be meant, it is just the principal diagonal of the matrix. Okay. And that's it. So types of matrix, matrix number 1, square matrix. This is the general matrix, this is square matrix, and this is the diagonal matrix. And let me draw another matrix for you, matrix D, and this time again this is square matrix, isn't it? So I am going to have 3, 0, 0, 3. Here this square matrix has its order 2, isn't it? 2 rows and 2 columns. But here in this case you can see that the principal diagonal is having only one number, which is 3. So I call this matrix as scalar matrix. So this is another type of matrix coming under the category of square matrix. Okay, this is a pure square. This is a pure square matrix, and here since the diagonal contains the non-zero values, only the diagonal contains the non-zero values, we can call it as diagonal matrix. And if the diagonal matrix is having only one number written in its diagonal, we can term it as scalar matrix. And another thing is, if there is a matrix having 1 in its diagonal and all others 0, we call it as identity matrix. What is that? Identity matrix of order 3, isn't it? This is a 3 by 3 square matrix. Okay. Usually I can also name this matrix as I3. This is identity matrix of order 3. So these are the types, basic types of matrices. So in the next class we will see how to operate between two matrices, how to operate just like addition, subtraction, multiplication, etc. between the matrices. Okay. So hope the video is clear for you. If you like the video, please subscribe to the channel baseyourbtech, and please do share with all your friends. And till we meet in the next class, this is Minu signing off. Thank you and take care.